Apache Doris is an open source real-time data warehouse. And as an open source project, it just graduated from the Apache incubator last year, but it has actually gone through 10 years of development. And so far, it has a user base of over 2,500 enterprises. And we have a busy release schedule. And recently, just last month, we released our version 2.0, which is kind of a breakthrough for us because it has a lot of great features, and I will talk about them later. And the Doris community is fast growing. It is now one of the world's biggest open source project in the data area by the number of monthly active contributors. So what Doris does in the data pipeline is it collects data from various data sources, like the relational databases, the big names, MySQL, PostgreSQL, SQL Server, and Oracle. It can also collect your logs, your time series data from your IoT devices. And then when you have this data in Doris, you can generate reports, you can do ad hoc analysis, federated queries, and the like. So on the application side, you can use Doris to support your dashboarding. You can build your self-service BI platform. You can analyze your sales, orders, and user behaviors. And of course, when it comes to data ingestion, you might need some extra tools. And Doris can be well integrated with Spark, Hive, Flink, Airbyte, dbt, and Fivetran. And it can also be connected to data lakes such as Hive, Hoodie, Iceberg Delta Lake, and the newly emerged Apache Pymon. And when we talk about real-time databases or real-time tools, the first thing that people look into is speed, right? So for your reference, these are the TPCH benchmarking results of Doris against some of the great products on the market, Presto, Greenplum, and Lakehouse. And as it shows, Doris has a competitive edge. It can respond to all these queries in a much shorter time. And we know some of these tools are better at flat table processing, but Doris is also competent in SSB benchmarks. So these are the comparisons against other products. And as for Doris itself, it has been actively evolving during the past 2 years. It has increased its performance by over 10 times compared to its early versions, and both in complex queries and flat table queries. And of course, all these tests are done in the same environment, and you can refer to the setup here. And this is a peek into the speed of Doris, and it looks promising, but after all, it will be slightly different for every use case. So what's more important than the benchmarking results is the design and features of the tool that enable it. So in the next part, I'm going to introduce to you the architectural design and a few features and mechanisms that contribute to the high performance of Doris. First of all, Doris has a cost-based query optimizer. It can figure out the most efficient execution plan for the complicated big queries. And it has a fully vectorized execution engine that can reduce virtual function calls and cache miss. And it's MPP-based, that means it's good at parallelism, so it can give full play to your machines and cores. And then in Doris, query execution is data-driven, which means whether a query gets executed is determined by whether its relevant data is ready. So that can enable more efficient use of CPUs. And these are the efforts we made in architecture and orchestration. And besides these, Doris has a few other ways to speed up the queries, including a rich collection of indexes, and it also has materialized fields and a comprehensive caching mechanism. So in essence, Doris, it's a column-oriented database. What's good about that is that it can make data compression and data sharding easier. But in some cases, for example, when you need to provide customer-facing services with your data platform, you will have many users requesting data from your system at the same time. But each user only asks for a small piece of data, like 1 or 2 rows. And these are what we call high concurrency point queries. And in these cases, especially when your data is arranged in flat tables, having a columnar storage engine will amplify your I/O operations per second. So to fix that, we have enabled hybrid storage, which means you can have both row storage and columnar storage at the same time. And also for these queries, especially since they are simple queries, it will be unnecessary and kind of wasteful to call out the query planner. So Doris executes a short circuit plan for these queries to reduce overhead. And another big source of overheads in these cases is SQL passing. For that, we have prepared statement. The idea is to pre-compute the SQL statement and then cache them. So when you have many similar queries, you can just reuse these statements in the cache. And next, I'm going to follow the data flow and show you how you can use Doris. The first step is data ingestion, of course. And Doris provides a wide range of methods for you to choose from. Like for real-time streaming, you can use Streamload, which is a way to write local files or data streams. And this method is linearly scalable. And in some of our use cases, this can reach a throughput of 10 million records per second. And then we have the Flink Doris connector. It is what we built to ingest data from OLTP databases to Doris. And as the name implies, it has built-in Flink CDC. And so far, we have realized auto-synchronization of data from MySQL and Oracle to Doris. And if you're a user of Apache Kafka, you might want to know about routine load, which is to subscribe data from Kafka message queues. And if you try to do ETL in Doris internally, which means you want to write data from one Doris table to another, you can try insert into, which if you are familiar with MySQL, you should have no frictions with. And then for batch writing, we have Spark load and broker load, which are the ways to write data from HDFS and object storage to Doris. And with Spark load, you can leverage the Spark resources to pre-compute the data before you write it to Doris. And if you try to build a data lakehouse, you can apply this simple statement called insert into internal table, select from external table. It is how you connect Doris to different storage systems, data lakes, and databases. And we've also been expanding our ecosystem. So besides the Flink connector, we also have Spark connector. And currently we are working on a data migration tool called X to Doris. And it will have a visual interface, so it's going to be very user-friendly. And we are also working on the parallel load and read-write separation, which will be available with our next release. And now with your data already loaded in Doris, the next thing you do is to keep your data updated, right? And if you look around the database world, you'll find that most data updating mechanisms are just not designed for real-time analytics. Like some of them update on the data partition level, which is not fine-grained enough. And some of them implement merge on read or copy on write, which is still not suitable for frequent updating. And of course, transaction processing systems are good at real-time updating, but they are short on analytic capabilities. So what Doris has to offer is that it supports both merge on read and merge on write. And the former is for low-frequency batch updates, and the latter is for real-time writing. And the merge on write mechanism will improve your query speed by 5 to 10 times compared to merge on read. And then from an implementation perspective, data updates can be divided into a few types. And a common one among them is upsert, which usually means you replace or update a whole row. And we also have partial column updates, and that means to update just a few columns in a row. And sometimes you have to do conditional updating, which means you filter out some data by combining a few conditions, and then you update or just replace and delete them. And sometimes you also need to replace a whole table or a whole data partition. And these are the common updating operations, and Doris supports them all. And also, in some cases, data updates will just happen concurrently. And that means you have many new data flowing in, trying to modify your existing one. And in these cases, the order of updating will matter a lot. So that's why Doris allows you to decide the updating order. You can say, let's follow the order of transaction commit, or let's follow the order of the sequence column, which is something that you specify in your table in advance. And so far, we've been talking about speed, either the speed in queries or the speed in data ingestion. But Doris also pays attention to service availability. And architecturally, Doris has two processes, which are front-end and back-end, as this figure shows. The front-end nodes manage the metadata, and the back-end nodes execute the queries. And they can do auto data balancing and auto restoration. And both the front-end and back-end processes are scalable. And when you need to upgrade or scale your clusters, you don't need to stop the whole system. And so you can avoid interruptions to your services and business. And then for data reliability, Doris supports snapshot backup and snapshot restoration, both at the table level and at the partition level. Now, for enterprise users, especially those in finance or e-commerce, they would need to back up their clusters or even their entire data center, just in case of force majeure. So in Doris 2.0, we have CCR, which is cross-cluster replication. And these are what you can do with CCR. Like I mentioned, you can do disaster recovery, and it also allows you to separate your read and write operations, because you can then have one master cluster and one slave cluster. So you have one cluster for reading and one for writing. And when you need to upgrade your clusters, it allows you to pre-create a backup cluster, so we can run things on the backup cluster for tests or to clear out any incompatibility issues or any bugs you may encounter. So how does Doris CCR perform? And in our tests, it's able to reach a data latency of minutes. And if everything goes well, your data synchronization speed will only be limited by your hardware. And then we come to multi-tenant management. Doris has sophisticated role-based access control. It allows fine-grained privilege control, like on the level of database, tables, rows, and columns. And then for resource isolation, in these cases, Doris used to implement a hard isolation plan, which is to divide the backend nodes into resource groups and assign the resource groups to different workflows. It was simple and neat, but one problem is that you don't make the most out of your resources because sometimes some resource groups are just idle. So we have improved on that. And instead of resource group, we now have workload group. And we set a soft limit for a workload group about how much resource it can use. And when that soft limit is hit, and meanwhile you have some idle resources in your system, those idle resources will be shared across the workloads to share the burden. And you can also prioritize the workload groups to say which one can get more resource and which less. Now, if you worry about would Doris be hard to grasp or difficult to get started with, let's just say that Doris is compatible with MySQL protocol and it supports standard SQL and it can be connected to most BI tools on the market. And this is another feature I would like to talk about. It's called flight schema change. This means if you need to add or delete some columns of your table, you can just update the metadata in the front end, which is quick and simple, but you don't have to modify all your data files. And this can be done within milliseconds. And it also allows you to do other changes like to the indexes or to the data types of columns. And if you use this feature in combination with the Flink Doris connector, as I mentioned, you will be able to synchronize your data to the upstream tables in milliseconds too. And these are the efforts we made in expanding the capabilities of Doris. And speaking of this, you would think of logs, you would think of observability data, security data, and time series data. And in these cases, people are looking for schema-free support. People are looking for lower costs and capabilities in multi-dimensional analysis and full-text search. So Doris makes optimizations to support them. Like in text analysis, mostly people use an operator, which is the like operator. So we put a lot of effort to improve the performance of that. For example, we introduced the n-gram Bloom filter, and we also push the like operator down to the storage layer so we can reduce the amount of data scanning as much as possible. And then we have also introduced inverted index for text tokenization and full text search. And the inverted index is a powerful tool for fuzzy keyword search and equivalence queries and range queries. And then to fit in with more data structures, we have compound data types. Like besides array, map, and JSON, we are now working on the variant type, which means you can put various data types into one field, and it's going to be available in our next version too. And of course, we have also made some improvements in storage and writing accordingly. And if you want a faster data lakehouse, or if you want to build a unified query gateway, you can look to Doris too, because it can map, cache, and auto-refresh the metadata from external sources. It supports Hive Metastore and almost all open data lakehouse formats. You can connect it to relational databases, Elasticsearch, and many other sources. And it allows you to reuse your own authentication system on the external tables, like reuse what you have in Kerberos and Apache Ranger. And then with all this done, we have benchmarked Apache Doris against Trino to see how it works. So it turns out that Doris is 3 to 5 times faster than Trino in queries on Hive tables. And how do we do that? It is the joint result of a few features. And first of all, the Doris query engine is efficient. It can cache the hot data locally. And we have a special solution called compute nodes. And these are different from what we usually have as backend nodes. These nodes are stateless and they do not store any data. So during computation peak times, these compute nodes can flexibly join the clusters to share the computation burden. And lastly, Doris allows you to write the computation results of external tables into Doris to form a view. And this is a similar thinking to materialize fields. So when you execute a query on the external tables, you can put the results in Doris internally. And then when you have similar queries following up, you can just directly read the previous results from Doris, and that makes things faster. And then this is another big job we've done in the new version 2.0. We have enabled tiered storage, and the main purpose of that is to save money for you, because it allows you to put your hot data in the quick but expensive disks, and then your cold data in object storage, which is more cost efficient. And with hot data, we mean the data that you frequently access, and cold data that you don't. So roughly speaking, if 80% of your data access is cold data and you put it all in object storage, you will be able to reduce your storage costs by around 70%. And this number is calculated based on the AWS pricing for S3 and HDD and SSD. So number may be different in your case, but generally this is a big money saver. So this is it. This is what I find amazing about Doris, which again, it's an open source real-time data warehouse. And if you have any questions about this talk, or you want to know more about any aspects of Doris, these are where you can find us. And I strongly recommend you to join us on Slack, because you'll be able to directly talk to our developers and many users.